In today's lecture of class 9th, the chapter is matter around us pure, and the topic we are studying separation of mixtures by of two solids. It can be done by several methods, out of which the first method is separation by a suitable solvent. So this method is used when in a mixture two constituents are there, out of which one is soluble in the given solvent and the other is not. So let's understand this with an example. To separate a mixture of sugar and sand, if we have a mixture of sugar and sand, and we know that sugar is soluble in water whereas sand is not. So when you dissolve the sugar in the sugar and sand mixture in water, what will happen? Sugar will get dissolved but sand will not. So it happens that when sugar get dissolved, you can separate by filtration method, you can separate the sand, and after that by the evaporation method we can get back the sugar crystals also from that solution. So by this method we can separate sugar and salt. Now similarly, we can see that in the mixture of salt and sand, this method is also applicable because salt is soluble in water but sand is not. And in the mixture of sugar and salt, sugar is soluble in alcohol but salt is not. So in the given methods, here you can see that water is the suitable solvent, and in the mixture of sugar and salt, alcohol is the suitable solvent. So by this method is used by using a suitable solvent. Let's take one more example to separate two solid substances by using a suitable solvent. The mixture of sulfur and sand we have this time. Sometimes any of the constituents are not soluble in water. Like in that case of sugar and salt, also we have seen that we have used alcohol, but in that case both of them were soluble in water. But in this case, sulfur and sand both are not soluble in water, means water we cannot use. So now what we can use? As in above mixture, sulfur is soluble in carbon disulfide because it means that we have to get some other solvent also which can dissolve the given constituent of any mixture. But sand is not soluble in carbon disulfide. So first we dissolve the mixture in carbon disulfide. So what will happen? Sulfur will get dissolved and sand is separated by filtration. Then by evaporation we get the sulfur as solid form back again. Similarly, sulfur can be separated from its mixtures with sugar and salt and carbon also. Means from out of these mixtures like sulfur plus sugar, sulfur plus salt, or sulfur plus carbon, we can get back the sulfur by this method.
In A part, we have taken sugar and salt mixture. In B part, on adding water, sugar gets dissolved whereas sand settles down at the bottom of the beaker. In the C part, on filtration, you see the sand remains on the filter paper and sugar solution gets separated. And after that, by the evaporation from the sugar solution, we can obtain the sugar crystals back again. So by this method, we can separate two solids from their mixtures.
The next method to separate two solid particles or two solid substances from their mixtures is by sublimation. This method is used when any substance is sublime in nature. Let's understand by some definitions. The changing of a solid directly into vapor on heating or vice versa is called sublimation. And the solid substance undergoing sublimation is called sublime. Plus the substance obtained by cooling the vapor is called sublimate. For example, like already we know the camphor is the basic thing which we use as the very important you can say the part of our daily life in which we do the worship and all. So camphor is very much used. When we heat it, then it is directly vaporizes from solid state. So this is the process called sublimation. From solid to gas or from gas to solid, both are known as sublimation. Second is the substance which undergoes this process is called sublime, means camphor is the sublime substance. And when we try to cool down the camphor vapors and we get back the particles of solid that camphor back again, you can say the powder form, that is called sublimate. Some examples other than camphor are ammonium chloride, iodine, camphor already I have explained, naphthalene and anthracene. These are the sublime substances which undergo the sublimation process. Now This process is used to separate that part of mixture which sublimes on heating, other part being non-volatile. Means if in a part of mixture, one part is sublime in nature and the other part is non-volatile. Non-volatile means on heating which does not, you can say, vaporize easily. Now, very importantly, most of the solid substances do not undergo sublimation, like common salt, sand, iron fillings, sulfur, chalk, whatever etc. substances which we use for the chemical reactions to check, or in the daily life also we have seen, these are not sublime in nature. Now let's understand this process with an example. To separate a mixture of common salt and ammonium chloride, as already we have discussed, common salt is non-sublime in nature and ammonium chloride is sublime in nature. So what will happen? In the above mixture, ammonium chloride sublimes but sodium chloride does not. We take this mixture in a china dish covered with inverted funnel, closed from top by cotton. On heating china dish, gently ammonium chloride sublimes and its vapor on touching cold walls of funnel will get stick to it in solid form again as sublimate, and sodium chloride is left in china dish. In this form we have separated by this method the ammonium chloride as the sublimate on the wall of the funnel and sodium chloride in the china dish itself. So this method is used in this way.
In this diagram you can see the separation by the sublimation method, as by the from the mixture of ammonium chloride and sodium chloride. On heating in the china dish, you see the vapors of ammonium chloride rising up, and on cooling by touching the cold walls of the funnel, they get sticked on the you can see the funnel walls, and sodium chloride is left behind and they get separated.
The next method to separate two solid substances from their mixture is by using a magnet. So already we know that magnetic substances as iron, nickel and cobalt get attracted towards the magnet. So this method is used in that mixtures where these kind of magnetic substances are present. For example, to separate mixtures of iron fillings and sulfur powder. As we take a horseshoe magnet near the mixture, iron pieces stick to the magnet whereas sulfur left behind. By repeating this process few times, we can get complete separation of the mixture, all the sulfur powder will be left behind in the container and iron fillings would have been sticked to the horseshoe magnet. So similarly, we can use this method to separate iron pieces from carbon powder, sand, sawdust, because these are non-magnetic substances. And it is used in industries to remove iron impurities from several substances. Also, the separation of scrap iron. This method is used in factories. Scrap iron is separated from the heap of waste materials by using big electromagnets fitted to a crane. So crane, when electricity is passed, this electromagnet attracts all the iron pieces present in the heap of the waste materials, out of which the materials which contain iron or the magnetic substances, they get attracted on the electromagnet. They are shifted to another place, and when the electricity is stopped, then all those pieces get separated and get collected at the different place where we want them.
In this diagram, in the above picture, you see that horseshoe iron is used to separate the iron fillings from the sulfur powder. The mixture of the iron fillings and sulfur powder, because iron is a magnetic substance, whereas in the crane, an electromagnet is used to take out the iron scraps from the waste materials from the industrial areas, or from where the heavy iron particles are to be removed.